Hey there, Data Dynamos. Welcome to a dazzling new adventure in our series. Today, we're stepping away from full-on XAI, but sprinkling its flavor with decision tree regression on the Diamonds dataset from Seaborn. I'm running this in Google Colab, slicing it into clear code blocks so you can tag along. We're diving into diamond prices, carats, cuts, and all, training a decision tree to predict them and plotting its structure to see how it thinks. Decision trees are naturally interpretable, giving us that XAI vibe without the heavy lifting. Grab your jeweler's loupe. Let's uncover some sparkling insights. Let's start by assembling our toolkit like master craftsmen. In Colab, I load up the essentials. NumPy for number crunching, Pandas for data shaping, Seaborn to fetch the Diamonds dataset, and Matplotlib's PyPlot, our canvas for the tree plot. From Sklern, I grab decision tree regressor and plot tree for modeling and visualization, plus train test split, mean squared error, and our 2 score for splitting and scoring. No interpret library today. We're keeping it raw with Sklern's tree, but its clarity adds that XAI touch. Now the dataset. I load it with Seaborn's load dataset diamonds and drop nulls with dropna. None to drop. Actually, it's pristine at 53,940 rows. The head shines bright. Carat 0.23, cut ideal, color E, clarity SI2, depth 61.5, table 55, price 326, X 3.95, Y 3.98, Z 2.43. Diamonds galore. Let's polish them for regression. Before we model, let's admire this Diamonds dataset. It's a gemologist's dream. We've got 53,940 diamonds, each with carat weight, cut, ideal, premium, etc. Color, D to J, clarity, I1 to if, depth, percentage, table, top facet width, price, our target in dollars, and X, Y, Z, dimensions in millimeters. That head, carat 0.23, price 326, small and affordable. Carat 0.31, price 335, slightly bigger, pricier. Cut, color, and clarity are categorical, but we'll focus on the numeric 6, carat, depth, table, X, Y, Z. Perfect for regression. This data is from real diamond listings, a treasure trove of size and value. I set X as those 6 features and Y as price, then split with train test split, 20% test, 80% train, random state 42. No nulls to fret. 53,940 intact rows, ready to shine. Time to craft our decision tree, a regression powerhouse. Decision tree regressor predicts numbers, not classes, splitting data into branches based on feature thresholds, like if carats under 1, price might be low. I initialize it with max depth 4, capping it for a readable plot, and random state 42 for consistency. I fit on X train and Y train, then predict on X test. The results? Mean squared error 1,982,618.2985. Root that, about $1,400 off per prediction. R squared 0.8753 to 87.53% of price variance explained. Not perfect, but solid for diamond prices ranging from 326 to 18,823. Why max depth 4? Deeper trees over fit. This keeps it simple and visualizable, adding that XAI-like clarity. Let's explore its guts. Now, let's dissect the tree's structure. It's where the XAI flavor sparkles. The tree has 31 nodes, underscore nodes from DT_regressor to tree underscore. I grab children left, children right, feature, and threshold arrays, then parse with a stack to compute depths and leaf status. Root node 0 splits on X column 0, carat, at 0.995. Left to node 1 if carat less than or equal to 0.995. Right to 16 if bigger. Node 1 tests Y, column 4, at 5.535 millimeters. Left to 2, right to 9. Down at node 3, carat less than or equal to 0.465 splits to 4, leaf or 5, leaf. Endpoints with price averages. The printout, node equals 0 test node, Go to node 1 if caret less than or equal to 0.99, 5L16. Down to node equals 4 leaf node. Leaf count, 16. Half the nodes, predicting prices like 500 or 1,500 based on splits. This tree's a roadmap. Caret's the kingpin. Let's zoom into that output. It's a diamond mine of info. MSE 1,982,618.2985 means predictions stray $1,400. Decent for prices from 326 to 18,000 plus, but room to polish. Our superscript 2 0.8753 to 87.53% explained. Shows strong fit, though not flawless. Diamonds are tricky. The tree structure's 31 nodes start with caret 0.995. Small stones, node 1, versus big, node 16. Node 2 splits caret at 0.465. Tiny gems under $500. Node 16 hits Y at 7.195 millimeters. Big dimensions, big bucks. Leaves like node 4 or 19 hold price averages, say for $100 or $8,000, based on those paths. Caret drives the route, but Y width, recurs, size matters. This isn't XAI's full toolkit, but the tree's splits scream interpretability. Small caret, low price. Here's the visual payoff. PLT.figure, size 16 by 8, and plot tree with feature names from X columns, filled boxes, rounded edges, font size 10. On screen, you're seeing a tree rooted at caret less than or equal to 0.995. Left branch green, low prices, right red high. Depth 1, Y less than or equal to 5.535 millimeters. Left dips to caret less than or equal to 0.465. Right to caret less than or equal to 0.894. Leaves at depth 4 show price predictions. Green boxes around $500, redder ones past $5,000. Caret's the top split. 0.23 caret diamonds cluster low, 1 caret jump high. Y's thresholds like 7.815 millimeters at node 24 split big stones. $10, 000 plus territory. Filled colors shift from green to red as prices climb. Intuitive and XAI-esque. It's a decision map. Trace caret and Y to price. Let's parse this tree deeper. It's a decision-making jewel. Take node 9. Caret less than or equal to 0.895. Then Y less than or equal to 5.725. Leaf 11 might average $1,000. Leaf 12, $2,000. Node 24. Y less than or equal to 7.815. Leaf 26 could be $8,000. Leaf 27, $10,000. Depth 4 caps complexity. 31 nodes, 16 leaves, each a price bucket. Compare node 4, caret less than or equal to 0.465, X less than or equal to 4.625, to node 29, Y less than or equal to 7.815, depth less than or equal to 66.2, small versus huge diamonds. The printouts if X:0 less than or equal to 0.995 matches the plot's route. Caret's king, but Y's a prince. MSE's $1,400 error leaves average prices, smoothing quirks. Our superscript 2, 87.53%, proves it's catching trends. This tree's a story. Big caret, big Y, big price. XAI flavor without the full toolbox. What's the takeaway from this glittery run? The head's caret 0.23, price 326 versus caret 0.31, price 335 sets the stage. Small price jumps. MSE 1,982,618 and our superscript 2 0.8753 show solid prediction. $1,400 off isn't bad for diamonds topping $18,000. The tree's 31 nodes, rooted on caret, branching on Y, tell us size drives value. Node 0's 0.995 split is the diamond divide. Leaves like node 8 or 30 hold prices, $500 to $12,000, based on paths. The plot's green to red flow mirrors that. Small caret, low price, big Y, sky high. It's not interprets XAI, but this tree's clarity is a taste. Imagine jewelers. Caret's your price lever. Let's polish this off. We nabbed the diamonds dataset, a sparkling hoard, trained a decision tree regressor to 87.53%, our superscript 2, and plotted its 31-node soul. Caret and Y ruled the splits, leaf prices shone through, and that MSE showed room to grow. This isn't full XAI, but it's interpretability, those if caret less than or equal to 0.995 rules. Adds the flavor. Grab this code, tweak max depth, watch that tree bloom. I'm buzzing from this diamond dig. Hope it's at you gleaming too. Next time, we'll sparkle brighter. See you then.